Out of Thomas's Calculus, section 5.5, we're doing U substitution with definite integrals. I want to let U equal to something because I don't know how to integrate this thing. I don't have a formula for it. I could let it equal the sine of t over 2, but that really wouldn't do anything for me. I could let it equal the cosine of t over 2, and that would get rid of my sine of t over 2 dt, but I'd still have this negative 1 minus u, and I'd have to square it out. And you could do that. That would actually work. It's just not the smart substitution. It's not the smartest substitution, but it would work. So I'm going to let u equal 1 minus the cosine of t over 2. And definitely experiment with things like that. Working things many ways is always a good approach, especially in this part of calculus. So we're going to differentiate both sides. So we get du equals the derivative of 1 is 0. The derivative of the negative cosine of t over 2 is I'll just do that. I don't know how good you are at derivatives. So we'll have that minus times negative 1/2 sine of t over 2 dt, and then we'll say du equals 1/2 sine of t over 2 dt, and then I have a sine of t over 2 dt over here, and I have a sine of t over 2 dt here times 1/2, so I can just say that 2 du equals the sine of t over 2 dt, and now I can just substitute directly in. I can, for sine of t over 2 dt, I can substitute in 2 du, and for 1 minus cosine of t over 2, I can substitute u, because I said so. Well, I mean, I've made that statement. It's not me personally saying say so. We agreed on this, or at least I did for you. So 1 minus cosine of t over 2 is u, so I have u squared. And then now sine of t over 2 dt is equal to 2 du. And I'm just going to bring that 2 out in front and write that as u squared du. And then, of course, we'll have 2 up by, and then u up by a power of 1 is u cubed over the new power plus c. And then we'll sub back in for u, and we'll get 2 over 3 times 1 minus the cosine of t over 2, because that's u cubed plus c, and that's it, even though that doesn't look like a c. And that looks more like a moon, but anyway, I don't know why I'm doing that. Anyway, that's it.